Hello, so today we're going to talk about how to solve a linear equation and a linear inequality based off our knowledge from Algebra 1. Okay, so a linear equation is something that looks like this. It's an equation that has either a single variable or multiple variables in the equation. The whole goal is to get the variable completely by itself by moving any other number to the opposite side of the equation and then combining like variables if there happen to be more than one in there. So for this problem right here, we need to move the 4 and the 3. Since we're adding the 4, we will subtract by 4 from both sides. Get 3y equals 15. And divide by 3, which means y equals 5. So again, we're dealing with a general form of this equation. It's a very straightforward two-step equation. But this principle right here, whether it's 2 steps or maybe as many as 10 steps, it's still the same general concept. Combining like terms, moving numbers around to get the single variable by itself. Could be a whole number, could be a fraction. Just always understand that if you leave your answer in fraction form, make sure it's the fully reduced form of the fraction, or you can write it as a decimal. So for a problem like this, we notice we have multiple y variables in the problem. We have a 7y, negative 2y, and a positive 3y. So we need to combine our like terms first. So 7 minus 2 is 5, plus 3 is 8. So this will become an 8y plus 4 equals negative 20. From here again, now we've combined like terms, now we move the numbers to the other side of the equation. So we'll subtract 4 first. Negative 20 minus 4 is a negative 24. We divide by the 8. Y equals negative 3. So again, multiple variables, combine like terms first, and then move other numbers around. If we have parentheses in the problem, which means we need to distribute the number on the outside of the parentheses to the numbers on the inside. So here we're going to move the negative 2 inside to get negative 6y plus 12, and then the 4 inside to get 20y minus 32. Now again, we combine like terms on the left-hand side, so negative 6y plus 20y is going to be a positive 14y. 12 minus 32 is negative 20. And again, it equals 92. So from here, we want to make sure that we've combined all our like terms, we again isolate the variable by adding 20 to both sides first. To get 14y equals 112. We then divide by the 14, the number in front of the y. And again, 112 divided by 14 is a positive 8. So y equals 8. So again, parentheses in the problem simply means we need to distribute the number on the outside to the numbers on the inside. When we have a bunch of fractions in our problem, generally the best option is to multiply everything by whatever the least common multiple of the denominator is going to be. So we see our denominators are 4, 3, and 5. So if we take a look at all the different multiples of these numbers, the multiple that they all happen to have in common would be a, looks like a 60. So if you list our multiples of 5, we have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. It wasn't until we got to 60 that we actually had a multiple of both 4 and 3 in the same problem. So if we multiply everything by 60, we'll clear out the fractions. So 3/4 times 60, well, 3 times 60 is 180. Divided by the 4 is going to give us 45. So it's 45z. 1/3 times 60 is just a negative 20. 2/3 times 60 is a positive 40, so it's 40z. And 1/5 times 60 is positive 12. So at this point now we have all fractions gone. Now we just have single whole numbers. Where again, we want to combine like terms, so we're going to move the 40z over by subtracting to combine with the 45z. And we'll add the 20 to combine with the 12. So we'll get 5z on the left-hand side and 32 on the right-hand side. So we divide by 5. For this particular problem, the number is not going to it evenly, so we can leave it as the fraction 32 over 5 because that's fully reduced. Or we can divide and get a decimal, which in this case would be 6.4. Both are perfectly acceptable. My general rule of thumb for decimals, if when you're dividing the fraction, to always round to nearest thousands place, so there'd be 3 digits after the decimal points. If it's exact like 6.4, there's no need to go 6.400. Now, sometimes the equations may not have any numbers in it, or they might have multiple variables, and the problem tells us to solve for a certain variable. So they want us to solve for m in this particular equation. Well, everything else that's not that variable m, we pretty much pretend are numbers. So c squared, since it's multiplying with m, we have to divide by c squared. So m will just simply equal e divided by c squared. And that's it, because now we have m by itself. So we call these equations literal equations. There are multiple variables in there. We're told to solve for a single one. Again, we do whatever operations we would normally do with numbers, but now we're dealing with variables. Now we might have situations like this where they want us to solve for z. We notice we have two different z terms, a yz and a bz. So when they were numbers, we would just subtract them over to combine like terms, which we still want to do. We need the z's all together. But in this case, we can't combine them into a single expression because b and y are not numbers. If it was like a 6 and a 3, we would just subtract them and get a number here. So in this case, we just leave it as our bz minus yz. So when we subtract that yz over, we get wx equals bz minus yz. Now again, the key is to solve for z, so in this particular problem, what we're going to do is we're going to factor the z expression out. Think of factoring as your reverse distributive property. So both terms have a z, so if we take it out, we can then set a set of parentheses with whichever is left over and we divide by the z. Take a z out of bz, all that's left is b. Take it out of yz, all that's left is y. Now if we're trying to solve for z, we divide by the b minus y expression. Because again, it's similar to if there was just simply numbers, b minus y is multiplying with z, so to get rid of it we have to divide the opposite operation. So z equals wx over b minus y. Okay, so they're a little more interesting when there are all variables, pretty much no numbers, but still the same general process behind solving it. Now, if we're dealing with the inequality, the process of solving the inequality is the exact same process as solving the equation. The only difference is if we were to divide or multiply by a negative number, we need to flip the inequality sign. But beyond that, everything else is the same. So since it's minus 15, we add 15, because we're trying to isolate x. So we get 4x less than or equal to 36. Divide by 4. Since we're not dividing by a negative number, we don't change our inequality sign, leave it as less than or equal to now 9. And that's all the problem is asking for. So again, same idea here. We're trying to solve for z. So we need to move the numbers around in the same way. So when we add 14 to both sides, we'll get a negative 6z is greater than or equal to a negative 18. And again, if we're trying to solve for z, we need to isolate it. So we now divide by the negative 6. Because we're now dividing by a negative number, we flip the inequality sign from greater than or equal to less than or equal to. And then we just do the normal operation. Negative 18 divided by negative 6 is a positive 3. So like I said, dividing by the negative is the only change in this problem. If we're doing something like this, it's called a compound inequality. This is where we have multiple inequality signs. The process for this is still the same idea. We work from the center outwards though. So normally we would have to add 3. Now not only do we add to the right expression, we also add to the left expression. So always work from our center outwards. So we get negative 6 less than or equal to 4y, less than or equal to 16. From here we just divide both sides by the 4. Again, same as we normally would for just a single inequality expression. That left fraction doesn't simplify to a whole number, but it does simplify the fraction though, so we need to write it in the simplest form, negative 3/2, less than or equal to y, less than or equal to 4. Again, if you want to write it as the decimal, perfectly fine. I typically leave answers in fraction form though. So again, another compound inequality, same idea. We work from the center outwards. So since we have minus 4, we'll add 4 from the center to the right and to the left. So we get negative 4 less than negative 2v less than 20. Now again, we divide by the negative 2. But we notice we're dividing by a negative number now. So in addition to writing the numbers out, negative 4 divided by negative 2 is a positive 2. We flip the inequality sign from less than to greater than. And then v, we flip the inequality sign again, and then negative 10. You can leave the answer in that form right there. If you like seeing the answers go from least to greatest, from left to right, you could rearrange it to say negative 10 first, less than v, less than 2. Just make sure that if you flip the order around, you're switching the left and right hand sides. You also flip the inequality signs at the same time. Alright, so that's the first video we have. This one's talking about solving equations and inequalities. Feel free to rewatch it at any point, and be sure to make sure you ask me questions in class regarding any material in here that you didn't quite understand. So I'll see you next time.